Gut, dann darf ich Sie alle ganz herzlich begrüßen. I would like to welcome everybody zu dem nächsten Jahr etwas mehr als eine Stunde, 1,25 Stunde. Die Präsentationen sind neben mir einmal von Vulcan Energy Resources Vincent Ledoux, Vice President und Business Development sowie IQ International Kevin Lohmann. So beside myself, the presenters will be from Vulcan Energy, Vincent Ledoux, he's Vice President Business Development, and of course IQ International Kevin Lohmann. Die Agenda für die nächsten, ja gut eine Stunde, ein bisschen länger, ist, ich werde jetzt einmal im Anschluss eine Präsentation vortragen zum Thema, die Automobilbranche will CO2-neutral werden. So I will give a short lecture on the topic, the automotive industry wants to become CO2 neutral. Diese Präsentation wird zweisprachig sein, this presentation will be bilingual. Um 5:15 Uhr, also 17:15 Uhr, wird dann Vulcan Energy präsentieren zum Thema CO2-neutrale Lithiumproduktion in Deutschland, 20 Minuten etwa. Dann gibt es noch einen Q&A für etwa 10 Minuten, da hatten Sie einige Fragen eingereicht. So at 5:15, Vulcan Energy will do a short presentation, roughly 20 minutes, regarding CO2 neutral lithium production in Germany, roughly 20 minutes, and then followed by 10 minutes Q&A. Diese Präsentation wird der Herr Ledoux auf Englisch halten. Sie haben aber die Möglichkeit, wenn Sie sich im Englischen vielleicht nicht ganz so sicher fühlen, ich hatte Ihnen allen Unterlagen zugeschickt, da finden Sie die Präsentation und dann eben auch die deutsche Übersetzung. Um 5:45 wird dann IQ International präsentieren, Gewinner des Green Tech Awards für seine 360 Mixing Technology at 5:45. IQ International, who is the winner of the Green Tech Award 2017, will present. Und diese Präsentation wird ebenfalls auf Englisch stattfinden. This presentation will be in English. Sie finden dann aber auch die deutsche Übersetzung mit dabei. And you will find the German translation within the presentation. Die Q&As selber werden immer zweisprachig stattfinden. Gut, es haben sich mittlerweile die meisten eingewählt. Dann darf ich mit der eigentlichen Präsentation zum Thema Automobilbranche will CO2-neutral werden. So the most attendees have dialed in meanwhile. Therefore, I would like to start with the first presentation, which is the automotive industry wants to become CO2 neutral. Bis 2015 möchte Volkswagen die gesamte Fahrzeugflotte klimaneutral produzieren. So until 2050, Volkswagen wants to produce its entire vehicle fleet climate neutral by then. Daimler hat da noch größere Ziele, die will dasselbe erreichen bis 2039, also 11 Jahre früher. Daimler wants to achieve the same goal 11 years earlier. Es geht sogar weiter, dass Volkswagen seinen neuesten Wagen sagt, dass sie soll neue Standards setzen unter Umweltgesichtspunkten. So Volkswagen also wants to set new standards an item of environmental aspects. Das Ziel ist es, dass ID.3 als erstes Wolfsburger Modell vollständig kohlendioxidneutral produziert wird. So the goal is that the ID.3 will be the first model to be produced completely carbon dioxide neutral. Das ist jetzt gar nicht so einfach, wie sich das anhört. So this isn't as easy as it sounds. Der Grund sind die Automobilzulieferer. Und wir haben ja freundlicherweise 2 Firmen dabei heute, die in diesen Bereich fallen. So the tip on the scale are the automotive suppliers. Warum ist das so? 70% bei der Herstellung von Autos werden von Zulieferern bezogen und im Autowerk dann überhaupt erstmal zusammengesetzt. Und nur 30% der Automobilhersteller beträgt die eigene Wertschöpfung bei den Automobilherstellern. So 70% is purchased from suppliers in the manufacture of cars and assembled in the car plant, and only 30% is the own added value of the car manufacturers. Das führt dann natürlich zu einem Problem, dass man einfach sagt, selbst auch die Automobilzulieferer müssen bereits einen Großteil zur CO2 Einsparung beitragen. So already the suppliers have to make sure that they do not produce a lot of CO2. Das geht auch sogar so weit, dass eine klimaneutrale Produktion inzwischen ein Vergabekriterium ist. So a climate neutral production an award criterion. So sagte der Daimler-Chef, dass die klimaneutrale Produktion ist für die Zulieferer inzwischen ein Vergabekriterium. So the Daimler boss mentioned that climate neutral production is an award criterion for suppliers. Das ist aber nicht der einzige Trend in der Vergangenheit. So this is not only the only trend which we see. Elektroautos sind auf dem Vormarsch, so electric cars are on the rise. Nach Schätzungen der Boston Consulting Group werden Elektrofahrzeuge ab 2030 vermutlich die Hälfte des weltweiten Automobilmarktes ausmachen. So the Boston Consulting Group estimates that electric vehicles will probably account for half of the global automotive market from 2030. Wir sehen momentan schon einen sehr, sehr starken Trend. Es hat derzeit eine Verdreifachung des Anteils an Elektroautos in Europa gegeben, so a tripling of proportion of electric cars in Europe. Und zwar innerhalb eines Jahres hat sich der Anteil der Elektroautos bei den EU-Neuzulassungen verdreifacht. So within 1 year, the share of electric cars in new EU registrations has tripled. Ein weiterer Trend, der zu sehen ist der Trend der Start-Stopp-Fahrzeuge, dass diese immer weiter zunehmen. And the further trend is that the start-stop vehicles continue to increase. In diesem Zusammenhang haben wir 2 Firmen heute, die sich gleich jeweils vorstellen werden. Die Firma Vulcan Energy Resources zum einen mal und die Firma IQ International. So we have 2 companies who will present themselves. First of all, Vulcan Energy Resources and afterwards IQ International. Worum geht es bei Vulcan Energy? Ganz kurz einmal umrissen. Sie bekommen gleich eine tiefere Einblick. So just in a nutshell, what is Vulcan Energy doing? Es geht um die Lithiumgewinnung und Weiterverarbeitung für Autobatterien und Elektrofahrzeuge. Und das Interessante dabei, wo findet das Ganze statt? In Deutschland, und zwar in der oberrheinischen Tiefebene. Die oberrheinische Tiefebene ist nach derzeitigen Schätzungen die größte Lithiumressource Europas. Und das Lithium befindet sich dort im tiefen Grundwasser. So, just in a nutshell, what is Vulcan Energy doing? So, lithium extraction and processing for car batteries and electric vehicles. And where? In Germany, in the Upper Rhine Valley. And the Upper Rhine Valley is estimated as the largest lithium resource in Europe. Where is the lithium? It's in the deep groundwater, which contains high concentration of lithium. Wie wird es momentan gemacht? Wo bekommt also die Automobilindustrie, wir haben ja noch recht viele Automobilindustrie in Europa, das Lithium her, wenn sie denn, soweit sie welches benötigt? Momentan werden große Mengen von Lithium, vor allem in Südamerika, aus Salzseen gewonnen. Das Salzwasser wird dort verdunstet. Und in Australien aus dem Bergbau gewonnen. So currently large quantities of lithium are extracted from salt lakes and especially in South America and in Australia by mining. Danach muss das Ganze noch zu Lithiumhydroxid verarbeitet werden. Das passiert normalerweise oder größtenteils, muss man dazu sagen, in China. So it has to be processed lithium to lithium hydroxide, and this is currently mainly done in China. Die Idee von Vulcan Energy ist, all das, sowohl die Gewinnung als auch die Weiterverarbeitung mitten in Deutschland zu machen. So the idea of Vulcan Energy is to do both the mining, the lithium extraction and the processing in the middle of Germany, so in the middle of Europe. Wie soll das Lithium jetzt überhaupt gewonnen werden aus der oberrheinischen Tiefebene? In einem ersten Schritt sehr, sehr einfach, und zwar mit Hilfe von bestehenden und künftig auch neuen Geothermalanlagen. und eine Erweiterung der Prozessschritte. Also man dockt sich praktisch an bestehende Geothermalanlagen in der oberrheinischen Tiefebene. Da gibt es einen Prozess, den Zero-Carbon-Lithium-Prozess, da wird dann aus dem heißen und lithiumreichen Tiefengrundwasser, welches bereits zur Energiegewinnung genutzt wurde, ein weiterer Extraktionsschritt angedockt praktisch und das Lithium entzogen, bevor es wieder in die Sohle zurückgepumpt wird. So, how does Vulcan Energy intend to extract the lithium in this area? With the help of existing and new geothermal plants and an extraction of the process steps. The process is a zero-carbon lithium process, and the first step is to use the hot and lithium-rich deep groundwater to generate energy in the geothermal plants. And in further extraction step, the lithium is extracted from the water and then pumped back into the brine. Wir haben hier ein ganz kurzes Bild, wie das Ganze ausschaut. Das heißt also, zuerst wird das heiße Sohlewasser, das ist sehr heiß, ich glaube 165 Grad etwa, hochgepumpt, zur Energiegewinnung genutzt. Danach wird das Lithium entzogen, dann wird das Wasser zurück in den Grund zurückgepumpt und das Lithium wird in Deutschland weiterverarbeitet zu Lithiumhydroxid. So you see just a short image. First of all, the groundwater is used to win energy within the used thermal plant, and afterwards the lithium is extracted and then pumped back into the ground. Das zweite Unternehmen, was ich hier gleich vorstellen werde, ist die Firma IQ International. IQ International ist ein multinationales Unternehmen für nachhaltige Technologien. So IQ International is a multinational sustainable company for sustainable technologies. Was macht IQ International? IQ International produziert und vertreibt hocheffiziente Bleisäurebatterien, die den gestiegenen Anforderungen an die Lebensdauer in den heutigen globalen Automobil- und Energiespeichermärkten gerecht werden. So what is IQ International doing? IQ International manufactures and distributes highly efficient lead-acid batteries that meet the increased need for cycle life in today's global automotive and storage markets. Ich habe hier ein kleines Bild, wie es einmal aussieht ohne die Technologie. Es ist also vor allem eine Durchmischungstechnologie, die Sie im unteren Bereich sehen. So it's mainly a technology with a mixing technology, which you see in the upper image. Sie sehen einmal auf dem Bild ganz links, wie sich die Platten nach etwa 210 Cycles ohne diese Mischungstechnologien aussehen. So you see at the left how the plates look after 210 cycles with no 360 grade mixing technology. Und darunter das Bild, wie es dann eben mithilfe dieser Durchmischungstechnologie aussieht. So and below you see image picture how it does it look like with the mixing technology. Gut, 17:14 Uhr, Zeit an den nächsten Präsentator rüberzugeben. So Vincent, may I ask you, are you online? Ich sehe, er ist eingewählt. Vincent?
Hello, can you hear me?
Yes, wonderful. I hear you perfectly. Thank you.
Okay, that's great. So thank you very much for the introduction. I feel like you've already done my presentation. But that's a very good introduction from your side. Just a few words on myself. So I've been working in the lithium industry for a bit more than 10 years now. My first job was actually working for a lithium mine in Western Australia, the largest lithium mine in the world. And then I had a number of consulting roles, mostly for specialty chemicals and basic chemicals as well. I was appointed by the European Commission last year as a lithium expert, and I previously worked for another European lithium project, and I led the project to be the first one in Europe to secure EU funding. And I've decided to join Vulcan because I really saw the alignment of the project with what automakers and battery makers are looking for, which is a greener way to produce battery metals such as lithium. So Eva, I think we can jump on the introduction slide. Perfect, thank you very much. So the goal of the company, as Eva explained, is to become the world's first zero carbon lithium projects. And we can achieve this by producing both battery-grade lithium hydroxide and renewable energy from geothermal brines located in Germany in the Upper Rhine Valley. I think we are actually located in the perfect place in Europe and in Germany, really in the center of the automotive and lithium-ion battery industry. And as you might know, Europe is going to become the second largest consumer of lithium in the world after Asia. But the issue we have in Europe is that we are currently not producing any lithium domestically. So if you talk to large automakers or battery makers, they are facing two major concerns. Is that if they want to be sourcing lithium, they are going to have to rely on China. Today, if you are an automaker and you want to secure lithium hydroxide, which is used in advanced batteries, you have 80% chances that you will be buying that lithium from China. The main issue is an issue linked to the supply chain of this lithium. We've seen it with COVID. We also see it with rising tension in international trade. People want to be able to source domestically as opposed to have to rely on global supply chain. And this is exactly what automakers are trying to do today. They are willing to source locally. The other issue is linked to the environmental impact of this lithium. If you are buying lithium from China, you're buying the dirtiest lithium you can find in the market today, and we'll see a bit later why this is. So our goal is to have a dual revenue generation. We are not just producing lithium, we are also producing energy and renewable energy. We have identified so far the largest lithium resource in Europe. It's also one of the largest in the world, and it is going to grow further. It's also a project advancing very quickly. We have published a scoping study earlier this year. We are now in the process of finalizing our PFS, what we published before the end of the year, and also finalizing the design of our pilot plants that will be implemented at geothermal operation next year. As Eva mentioned, I think we've got an existing agreement with a geothermal operator in the Upper Rhine Valley, and we've put together a team of experts on both the energy side and on the lithium side. And we are also one of only 2 projects in Europe supported by the EU, not just supported vocally by EU politicians, but also supported financially. Next slide, please.
Yes.
So one of the main ideas behind the project is that if we keep using traditional processes to obtain lithium, such as hard rock mining in Australia and refining in China, we are actually defeating the purpose of electric vehicles, which is to power a greener future. It was actually calculated that today, if we decide to convert every single traditional car in an electric vehicle, and that the battery in those cars is using lithium produced from existing production methods, this will generate, just for lithium production itself, more than 1 billion tons of CO2 emissions, which is enormous. So driving an electric car is not enough to decarbonize the supply chain. We also need to look all the way up to mining and change the way we're currently extracting lithium. Next slide, please. So you currently have 2 main processes used to produce lithium. The first one, and the main one, is hard rock mining in Australia. The rock which has been extracted from Australia is then exported to China, where it is converted into a lithium chemical. And the issue is not so much on the extraction, it's more on the conversion into the chemical product, because in China, the converters are using coal power plants, which means that it is emitting a lot of CO2 emissions. They're also using a lot of very harsh reagents like sulfuric acid. Then the other solution you have is to be sourcing lithium chemicals from South America. There you have less issues with CO2 emissions, however, they are also using a lot of natural gas, but the main issue is with water. It is one of the driest places on Earth, and they are using very large amount of waters for their evaporation plants, but also fresh water for their conversion into lithium chemicals. And we've seen a number of associations and indigenous communities fighting against this type of mining, so it's difficult to see how in the future automakers and battery makers who are looking for sustainable raw materials will keep sourcing lithium from this part of the world. Next slide, please. So I think we all know there's a lot happening in Europe, especially after COVID. We've seen the EU and a number of EU governments coming up with new incentives to push customers to acquire a new electric vehicles. And it is working because we can see the EV sales numbers keep going up. We actually see more investment in electric mobility today in Europe than in China. And in turn, those cars are going to require a lot of lithium-ion batteries. And Europe is also becoming the fastest growing center for the production of lithium batteries, especially in Germany. And in turn, those batteries will require lithium, and a lot of it. If you look at the global lithium market today, it's around 300,000 tons. And around a third of that is lithium hydroxide, which is a type of lithium you need for advanced batteries. 100,000 tons of lithium hydroxide is what we are going to need in Europe, and in Europe only in 3 years' time. So basically in 3 years' time, you need as much lithium hydroxide to what is currently produced in the world today. And obviously our issue is we currently don't produce any lithium, which is linked to two main issues, as explained earlier: a supply chain risk and a risk in terms of the environmental impact of this lithium production. And that's why we want to change things. Next slide, please. So the team at Vulcan knew that it was possible to produce a zero-carbon lithium using existing technologies, but we needed to find the right assets. We also knew that producing lithium from South American brines was going to require a lot of energy and a lot of water. So we decided to look for geothermal brines, because if you source a geothermal brine, the heat is already contained within this brine. But this is not enough. You need to look at 3 different factors to make it work. So you need the renewable heat, which is geothermal. You also need high lithium grade, so a high concentration of lithium in the brine. And you need a high brine flow rate. Those 3 components together are only available in 2 places across the world: in the Southern Sea, in California, and in the Upper Rhine Valley in Germany, where we are located. So we have decided to go for the Upper Rhine Valley for a number of reasons. The main 2 reasons are, first of all, we know that this is the fastest growing market for lithium, and there's currently no production in Europe. And the other reason is the brine composition in the Upper Rhine Valley is better than the one in the Southern Sea. The brine composition in the Southern Sea contains more impurities, like transition metals or silica, which makes it harder to convert into a lithium chemical product. Next slide, please. So there is actually a lot of data available in the Upper Rhine Valley, because it's a region of Germany which has been explored for many years, mostly for oil and gas. So we've gathered a lot of data. We've also put together our own data, and we've defined the largest lithium resource in Europe by far. It's also one of the largest resources in the world. So far, we have secured a license package of more than 800 square kilometers. This license package is divided into 6 licenses. 3 of those licenses are granted exploration licenses, and one of them is actually a production license, because we have an agreement with an existing geothermal operator, which means that we have access to live brine, which also means that we can test this brine, and we've been running a number of test work to see how much lithium we could extract from this brine. Next slide, please. And this is where we are in relation to our customers. We are not just offering to supply a zero-carbon lithium, we are also offering to de-risk their supply chain by being able to source lithium directly from Europe and from Germany. Typically, the companies which are listed on this map are companies we are engaging with, both in terms of supply agreements and also in terms of equity investments. Many companies which are not listed here because they are not currently planning on producing batteries or cathodes are a lot of energy and chemical companies which are very involved in discussing with us for potential equity investments in the company. Next slide, please. So I think Eva described it very well earlier, but just to add a bit more to it, we will be extracting this hot brine from the ground. And when I say hot, it's around 165 degrees. And because it is hot, it is going to generate steam. The steam will be used to power turbines, and those turbines will produce electricity. This is a typical geothermal plant. The electricity will be sold to the grid. And in Germany, when you produce electricity from a geothermal asset, you have a feed-in tariff, a fixed price of 25 cents per kilowatt hour. This feed-in tariff is guaranteed for 20 years. Once you produce your electricity, the brine is simply reinjected into the ground. But this will be a typical geothermal operation. We are not doing this. We're doing much more than this. So instead of reinjecting the brine into the ground, we actually divert the brine once the electricity has been produced, and this brine goes through what we call a direct lithium extraction plant. To explain it at a very high level and simplistic level, the brine will go through a number of different tubes or columns, and inside those tubes you have what we call an adsorbent or resin. The resin will capture or absorb the lithium from the brine and leave impurities and the water behind. So the impurities in the water will then be reinjected into the ground. It's very important to show to the German authorities that whatever we extract from the ground is also reinjected into the ground minus the lithium. The lithium which is extracted from the brine is a lithium chloride. This is not a finished product. It needs to be refined further into a lithium hydroxide, and we are going to do this in a central lithium refining plant, which is at a different location to where the geothermal and the direct lithium extraction plant is going to be located. The idea for us is to have a number of those geothermal plants and DLE facilities across our licenses, and to have one central lithium hydroxide refining plant which will be located at an existing chemical park. In a few years' time, you'll therefore be able to drive an electric car using green electricity from our side, but also an electric car using a zero-carbon lithium that is coming from our assets. Next slide, please. So it's very important to mention here that our process replicates existing operation currently taking place commercially across the world. So what's unique about our process is the combination of those different steps. So you have three main steps. The first one is geothermal. And geothermal energy has been around for ages. You've got hundreds of geothermal plants across the world, and you've got 37 of them here in Germany. And the Upper Rhine Valley is well known to have developed a number of successful geothermal operations. We have a team working with us here in Karlsruhe, where we are located. We have a team who has experience in permitting and building geothermal plants. I'm currently sitting in their offices actually in Karlsruhe, and we're targeting on having around 40 people working on the project by the end of the year. So the geothermal part of the process is very well known and pretty much de-risked. Now the next step of the process is the direct lithium extraction plants. Some people think that this is a novel technology. However, it's a technology that has been used for many years across the world, and mostly in Argentina. Livent, for instance, is one of the largest producers of lithium chemicals, and they've been using this technology for more than 25 years. And in China, you have a number of converters in the Qinghai province also using this technology. Basically, you have three types of main DLE technology. You've got adsorbents, ion exchange, and sorbents. We've decided to go for the first one, adsorbents, because this is the only technology which is currently commercially used in Argentina and in China as well. We are not looking at the moment at developing our own technology. We are looking at relying on a vendor to be supplying us this technology. And we have looked at 65 different potential vendors, and we've refined this selection to 3 players. We've tested the technology with brine from the Upper Rhine Valley, and we are currently in the process of refining those vendors to 1 player. And those players are all very large chemical corporations who are going to be able to support us in our project developments. And just to give you a bit more background on the test work we've already achieved, we've achieved very high lithium recovery from this brine at more than 90%. The last step of the process will be the lithium refining plants, because the lithium you obtain from the DLE site is a lithium chloride that needs to be refined into a lithium hydroxide that can then be sold directly to battery makers, cathode makers, and automakers. This refining will take place at an existing chemical park, which we are currently selecting. It will be in the region of Karlsruhe in the Upper Rhine Valley or in the region of Frankfurt. Next slide, please. And this is a very important slide because this is one of the reasons why it's important for us to be successful. It's important not just for us, but also for the auto and battery industry. This data was put together by a company called Minrivo. It's a consulting firm based in London, and they've put together a life cycle assessment for the production of lithium. And they looked at the different routes currently used to produce lithium. The first one is the largest way we currently produce lithium. It is hard rock extraction in Australia and its conversion into lithium chemicals in China. It is also the most polluting way of producing lithium. For every ton of lithium hydroxide you produce, you will generate 15 tons of CO2. Now, if you look at the production of lithium from South America, it is not as polluting, around 5 tons per ton of lithium hydroxide. However, the issue there is more on the water usage and on the chemical usage as well. And for us, we have the opportunity to have a negative carbon footprint because we are producing more energy than we consume ourselves. Once again, we're not just selling lithium, we are also selling energy. Next one, please. And what we're offering is not just a solution for automakers to be sourcing a great zero carbon lithium product, which is great for their marketing, but we are also helping them to potentially offset their CO2 penalties. If you look at someone like Volkswagen, for every single of their electric vehicles today, they will be emitting around 700 kilograms of CO2, and that is just linked to the production of lithium that will be used in this car. Now, Volkswagen is targeting the production of 28 million electric vehicles, which will mean that Volkswagen will emit more than 19 million tons of CO2 emissions just linked to the production of lithium itself. And we know that penalties are currently only targeting the end product, the electric vehicles. However, we also understand that the EU legislation is changing and will soon be targeting batteries and electric vehicles, metals such as lithium. So what we're offering is actually to offset some of those penalties by helping automakers to reduce their CO2 emissions and maybe offset some of the other CO2 emissions coming from the rest of their supply chain. Next slide. So once again, we are producing lithium and green renewable energy. On the lithium side, lithium prices have been pretty volatile during the last few years, during the last 3 years to be more exact, especially in the spot market. We've seen prices in the spot market moving between $8,000 to $22,000 per ton. However, the spot market only represents a very small part of the volume currently traded internationally. A majority of the volume is actually contract. It represents 90% of all volume. And on the contract part, prices have been concluded between $11,000 to $14,000 per ton. If you look, for example, at what's happening in South Korea, Japan today, prices are around $11,500 per ton. Now, if you look at production costs for South American brines, for lithium hydroxide, they will be roughly between $5,000 to $7,000 per ton. For us, we have a number of key advantages compared to those producers in South America. We have free heat because the heat is coming from our geothermal operation. We don't have to buy it from the grid or from another supplier. We have a very small usage of reagents. In South America, when you produce lithium hydroxide or lithium carbonate, your biggest cost is going to be your chemical needs. For us, the needs of chemicals is actually very small. And we also have a very short distance to markets. Our customers are right next door. We're not shipping it all the way to Asia. And we're selling a premium product. It's a zero carbon product, which is unique. And on top of that, we also sell energy. And we sell energy at a feed-in tariff, which is a fixed price of 25 cents per kilowatt hour. So those two revenue streams are really complementing each other, but also de-risking each other. Next slide, please. In order to be keeping track of time, I'll be quite quickly here, but the CEO and co-founder of the company, Francis Wedding, has actually been here for the last 4 weeks in Germany. He's currently based in Australia, and he's coming from the lithium industry. He was involved in the discovery of Pilbara, which is one of the largest operating mines for lithium in Australia. Dr. Horst Krutter is also the other co-founder of the company. He's Mr. Geothermal in Germany. He's leading a company here in Karlsruhe, who's been permitting and developing a number of geothermal projects both in Germany and globally. Next slide, please. And we also have a team of experts on the geothermal side and on the direct lithium extraction side. The lithium industry is a very small industry, and the DLE industry is a small industry inside a small industry. So you only have maybe up to 5 experts in the world in DLE, and we've got 2 of them. For example, Dr. Katharina Gerber recently moved from California to Germany here in the office. She was previously involved and working for the California Energy Commission, looking at a DLE project in the Southern Sea. Alex Grant is another technology expert. He co-founded Lilac Solution. Lilac Solution recently received $20 million from one of Bill Gates' funds, and he's working with us. And we recently appointed Jochen Rudat. Jochen Rudat worked at Tesla for 10 years. He was direct report to Elon Musk and is helping me on the business development side. And we have a number of chemical engineers, senior geochemists and geologists working here at the office in Karlsruhe. Next slide, please. And very importantly, we are also one of only 2 projects supported financially by the EU. It's not just a funding deal, it's also a collaboration deal where InnoEnergy, so InnoEnergy is a European entity who is investing EU funds in selected energy projects. They're also helping us in the permitting process, they're helping us in securing off-takers, and they are, let's say, incentivized to make this project successful. We're also obviously part of the European Battery Alliance, and we are one of the we are actually part of a number of European associations to develop this fully integrated lithium-ion battery supply chain. Next slide, please. So where are we today? We have finalized our scoping study earlier this year. We are currently finalizing our pre-feasibility study that will be published by the end of the year. And we are also finalizing the design of the pilot plants that will be implemented at geothermal operations early next year. Next year, we're going to be working on the DFS and running those pilot plants. Our target is to start commercial production of lithium hydroxide by the end of 2023, early 2024, and then we can really grow with the European market because the resource is so large that the more we want to produce, we just have to add additional wells and build new DLE assets and then send lithium chloride to the central lithium refining plant. The goal for us is to be able to produce roughly between 30 and 40,000 tons of lithium hydroxide in a few years' time. Next slide, please. We've been listed as Vulcan since the end of last year. You can see the share price has been doing quite well. This is actually not up to date, but fully diluted. The company is around $100 million Australian. Management owns a fair share of it. We've got a good cash position. It says 6 million here, but actually there's another $3 to $4 million coming from options, which are now in the money and investing in with a deadline for the end of the year. They're in the money at 28 cents, so we expect quite a fair share of it to be coming in during the next couple of months. We've appointed recently a London-based financial advisor called NRG, and we've been having a number of conversations with strategic partners that will be stepping in next year for the next step of our project developments. Next slide, please. And this is my final slide before we jump on the Q&A session. Just as a very quick reminder, we are the only zero-carbon lithium project in the world. We are one of only 2 projects supported financially by the EU. We have the largest lithium resource in Europe. We are located at the right place in Germany at the right time, with Europe becoming the second largest consumer of lithium chemicals in the world. And we have the right team for the job, with experts both on the geothermal side and on the DLE side. And it's a project that's advancing very quickly. And we are, again, finalizing the PFS, and all the numbers will be published in December. And that's it on my side for now. Eva, I'll let you take over.
Thanks a lot, Vincent. Vielen Dank. So we have 5 minutes left for 8 questions. So therefore it would be good if you just can answer the question with 1 sentence. Wir haben also noch 5 Minuten. Daher bitte ich gerade den Vincent, die Frage immer nur ganz kurz zu beantworten. Die erste Frage ist, wie ist der Zeitplan für die Kommerzialisierung des Lithium bzw. Lithiumhydroxids? So what is the timetable for the commercialization of lithium or lithium hydroxide?
Okay, so the timetable is next year we will be producing samples, so small volumes of lithium hydroxide, which will be sent out to potential off-takers. They will be testing and validating these products, but really for us, at a commercial scale, the target is end of 2023, early 2024, which is really when the European market on the lithium side is really starting to reach significant volumes.
Also erste Proben wird es geben im nächsten Jahr und der eigentliche Kommerzialisierungsprozess wird Ende 2023, Anfang 2024 starten. Wie viele Geothermalwerke sind in der rheinischen Tiefebene geplant, die ebenfalls zur Lithiumgewinnung genutzt werden? So how many geothermal plants are planned in the Upper Rhine Valley that will also be used to extract lithium?
Okay, so we have both brownfield and greenfield opportunities. We are actually talking to a number of existing geothermal operators to collaborate with them. But at the end of the day, we need scale. So even if we start producing lithium from existing geothermal operations, we want to be able to produce a lot more lithium. Therefore, the goal for us is to be building our own geothermal sites as well. And we will be building a number of them. And adjacent to those geothermal plants, we will also be building direct lithium extraction plants. We want to be able to reach a critical size of lithium hydroxide production, which is currently, if we look at existing geothermal operations, not possible to achieve. So therefore, we need to also build our own sites.
Also ganz kurz zusammengefasst, man konzentriert sich momentan auf bereits existierende Geothermalquellen, möchte aber deutlich mehr Lithium produzieren und daher ist auch geplant, künftig eigene Geothermalquellen zu erbauen, um dann eben aber auch gleichzeitig an der Produktion von Energie mit zu partizipieren. Welche Genehmigungen müssen noch eingeholt werden? Ist damit zu rechnen, dass es Schwierigkeiten bei den Genehmigungen geben könnte? Which permits still have to be obtained? Is it to be expected that there could be difficulties with the approvals?
Okay, so there are a number of permits that need to be obtained, like for any other project. At the moment, we've already have 3 exploration permits granted, and we have 1 production permit we have access to because of the existing agreement we have with a geothermal partner. We are going to submit a drilling work plan early next year to be able to drill our first well in 2021. We are targeting to do this at one of our licenses where we already have all the 3D data available, so we already know where we need to drill. And drilling for geothermal energy is very different from mining, because basically the first exploration well you're going to drill is also your first production well. So it's like saying in mining that your first drill hole is also your first shaft, basically. So it is very different. I mean, in terms of difficulties, any project will face some opposition. For us, it's very different because we're not looking at developing a mining operation in Europe with a large open pit and a chemical plant next to it. For us, it's a geothermal asset to start with. And you have many geothermal plants which are located in cities, I mean, like in Munich or in Paris, they are well accepted. And really the chemical part of our operation is going to be located at an existing chemical park. So in terms of permitting, it's a lot more straightforward, but let's say a typical mining operation that will be looking at building an asset in Europe.
Okay, das darf ich auch ganz schnell zusammenfassen, weil wir haben eigentlich müssen eigentlich jetzt zwischen umschalten. Eines der entscheidenden Unterschiede zur Mining ist, dass das erste Drilling, was man macht, im Grunde schon auch die erste Produktion ist. Das ist eben anders als beim Mining. Und es geht davon aus, dass es natürlich auch schon eine ganze Reihe von Geothermalanlagen gibt, dass der Genehmigungsprozess deutlich mehr straightforward ist. Wie wird das Lithium aus dem Geothermalwasser entzogen? Handelt es sich um etablierte Technologien oder sind das Technologien, die von Vulcan Energy entwickelt werden? So how is the lithium extracted from the geothermal water? Are these established technologies or are these technologies developed by Vulcan Energy?
So I think we've touched base on this during the presentation. There are three types of DAD technology: adsorbents, ion exchange, and sorbents. The only one commercially used today is adsorbent, and it is the one we're going for. We are not currently looking at developing our own technology. We are looking at relying on an existing supplier of this technology. We don't want to be an R&D project. We want to be commercially operating within the next 3 years, and therefore that is why we want to be relying on existing supply of this technology. There are plenty out there, some good ones, some bad ones, and we are currently refining this choice to one player who will be supplying us with the resin, so with the DAD technology. And bearing in mind this resin has already been tested, we've already been doing some test work, and we've achieved very high lithium recovery.
Also da ist es so, dass man auf bereits bestehende Technologien zurückgreift, die es seit vielen Jahren bereits gibt. Und da sind kürzlich erst noch Testergebnisse, in denen man genau das Lithium mit Hilfe dieser Technologien entzogen hat. Und da waren 90% Lithiumgewinnung aus dem Lithiumwasser gemeldet worden. So, welche Kosten entstehen für die Extraktionsanlagen? What are the costs for the extraction plants?
Okay, so during the last scoping study we released earlier this year, OPEX and CAPEX were not communicated. However, they will be communicated by the end of the year. If I had to describe the operation at a pretty high level, I would define it as high CAPEX and very low OPEX. High CAPEX because part of the operation is a geothermal operation. So around 50% of the CAPEX will be on the geothermal part, the rest on the lithium side. But bearing in mind that that 50% is pretty much a de-risked investment because it will be running by itself, selling electricity. On the OPEX side, the reason we are going to be so low on the cost curve is because we get free energy, first of all. We consume very little reagents, and we're also able to sell energy to the market. So it's a very different value proposition to a typical lithium operation.
Vielen Dank, Sixlot. Das ist also bisher noch nicht veröffentlicht worden, wird am Ende des Jahres veröffentlicht. Ich spute mich ein wenig, weil wir eigentlich schon bei IQ International sein müssten. Die nächste Frage war schon beantwortet worden, zu der Frage, wo die Extraktionsanlagen stehen werden. Dann in Deutschland und Euro entstehen ja bereits eine ganze Reihe von potenziellen Abnehmern, beispielsweise Tesla. Welche davon hat Vulcan Energy im Auge und gibt es bereits erste Gespräche? In Germany and in Europe, a whole range of potential customers, for example Tesla, are currently emerging. Which of these does Vulcan Energy have in mind, and are they already initial talks?
Yeah, absolutely. So we are talking to pretty much the entire lithium battery supply chain in Europe. For us, a direct buyer will be a cathode maker, and that will be someone like Chemical, Johnson Matthey, BASF, or Noble. However, battery makers and automakers are also looking at de-risking the supply chain and buying lithium directly. And we've seen it before, and you've mentioned Tesla, but we've also seen Volkswagen, BMW directly buying lithium themselves. And they've also stated publicly that they want to be sourcing sustainable raw materials. That includes lithium. Their goal is to become carbon neutral. And what we're offering today is a zero carbon lithium. So of course we're in discussions with all those players. And we are currently discussing around a number of commercial terms around volume, pricing, duration, etc.
Es werden bereits erste Gespräche geführt und natürlich sind dann auch Unternehmen wie VW oder Tesla, die eben das Lithium und vor allem nachhaltig gewonnenes Lithium benötigen, entsprechende Ziele von Vulcan Energy. Last question. Der Aktienkurs von Vulcan hat sich seit Ende 2019 in etwa versiebenfacht. Was sind die Ursachen für eine solche Entwicklung? The share price of Vulcan Energy has increased approximately by 7-fold since the end of 2019. What are the reasons for this development?
Yeah, I mean there are many reasons. I'll only list a few. I mean the size of a resource has been increased twice during the year. So it also means we've increased our position as the largest lithium resource in Europe. We've as well published a strong scoping study really highlighting the structure of the project. We've also published some test work results. We've shown that it was feasible to extract more than 90% of the lithium from the brine, Do you want to start with it, because I've got a few other points, so if you have to translate, that's going to be a bit long for you.
Also es gibt verschiedene Gründe, warum der Aktienkurs so gestiegen ist. Unter anderem sind die Schätzungen der Lithiumreserven in der oberrheinischen Tiefebene und in dem Bereich, in dem Vulkan eben Zugriff hat, zweimal nach oben korrigiert worden. Es sind Scoping-Study veröffentlicht worden und es hat auch eben erste Test-Results für das Extrahieren des Lithiums gegeben, die veröffentlicht wurden, nämlich diese besagten.
So we've also announced the funding deal with Energy, the European institution. So we are one of only 2 projects to achieve this. So I think that was very important. We've also appointed a number of experts, both on the direct lithium extraction side and geothermal side. So that was all along the year. The most recent appointment is the ex-direct report to Elon Musk, Joachim Rudat, who is now working for us. And we've also basically built more awareness around the project. As you probably know, things are moving very quickly in Europe. A lot of politicians and automakers are looking at developing the supply chain and helping a project to be producing lithium in Europe. It's very important, and the interest in lithium globally is really coming back at the moment. And just maybe to finalize on this one, we have a very unique profile, and investors and people start to realize that we're the only zero carbon lithium project in the world. We're located in Germany. We're supported by the EU. We've got a great team of experts, and we're a project advancing very quickly. So there are many reasons why the share price has been growing so far, but I think there are some of them here.
Okay, es sind also eine ganze Reihe von Experten eingestellt worden, eben auch ehemalige Tesla-Mitarbeiter. Es gibt eine sehr viel stärkere Wahrnehmung von Vulcan Energy, unter anderem auch in den politischen Gremien. Es gibt sehr viel, das Lithium, die Nachfrage nach Lithium ist gestiegen und ein sehr einzigartiges Profil. So thanks a lot. We have the next presenter is waiting. Thanks a lot, Vincent. And hopefully speak to you soon.
Sounds good. Thanks a lot, Eva. Thanks, everyone.
Thanks a lot.
Bye-bye.
Bye-bye. Okay, so I may ask Kevin. Kevin, are you already available?
I am. I'm here, Eva.
Wonderful. So thanks that it took a little bit longer. We will give you the same time at the end, of course. May I ask you just to start your presentation?
Yeah, absolutely. Well, thank you, everybody, for having me. And Eva, thanks for putting this all together. If you want to flip to the first slide, Eva, I'll try and walk through the slides here. So IQ International, just to give you a little bit of my background, I've been an investor in the company for a while, and I took over the CEO-ship almost 2 years ago at the December of 2018. We recognized early that the company had a very unique technology portfolio, and it was really underrepresented in the automotive sector. And so over the period of time, we've set up our global head office in Zug and North American head office in Scottsdale, Arizona, and we've moved the company back to the Frankfurt regulated stock exchange. Eva, if you could go to the next slide, please. So my background, I'm actually third generation in the battery space. My family's been in the space since the late 1940s, and the technology, the starter battery technology, has not evolved in almost that entire period of time, with the exception of some small innovations. And the reason for most of that is there was never a reason to do so. So although we recognize the vehicle fleet, as Vincent mentioned in the past presentation, is moving towards advanced energy systems. They're moving towards lithium. They're moving towards also fuel cell technologies as the hydrogen economy comes online. There's still a need, and will continue to be a need, for your starter battery. Next slide, please, Eva. A lot of people think today that electric vehicles or the lithium battery is replacing the lead acid battery, but that's just not the case. I think the first myth that we have to dispel so that people understand the reality is the 12-volt starter battery is still in every electric vehicle. And this slide that you see in front of us from Johnson Controls is showing you, what that battery is doing in today's more electrified vehicles. Even in the pure electric vehicles, most automakers have made the decision to remain with lead-acid batteries for the starting, lighting, and ignition application. What we do see happening over a period of time is the 12-volt lead-acid battery moving towards a 48-volt lead-acid battery, specifically in the mild hybrid or hybrid electric vehicles. And that's an area that we're focused on, and actually our technology portfolio allows us to address. Next slide, please, Eva.
Yes.
Move on to the next slide, please. This one, yeah. No, go back. Sorry, there's a delay. So what's happening in the auto sector? Why is the lead-acid battery for the first time in decades lasting a shorter and shorter period of time as of maybe 2011 or 2012? You're seeing your regular combustion engine move towards things like start-stop, regenerative braking, passive boost. And the lead-acid battery in those vehicles require almost 6 times the cycle life of a conventional flooded lead-acid battery that was in the previous automotive vehicles. But in addition to that, this slide shows you all of the electronic and comfort features that have been added over a very short period of time. And we've been fortunate to talk with a number of the major automakers, senior executives, and the industry never anticipated the rapid adoption by consumers of the electrification of comfort features. So if you think about the vehicles today, they're really a large computer on wheels. And our current lead-acid technologies have not kept up, and the incumbent manufacturers really have not focused on innovation for decades and decades because there's just never been a need for that type of innovation. Next slide, please, Eva.
Yes.
So when you look at it, if you go back 130 some years since the invention of the lead-acid battery, there's been the same issues killing the battery. The primary killer of the lead-acid battery is acid stratification, and this is just simply the separation of water and sulfuric acid over a period of time. This anomaly occurs in the first 20% of the battery's life, and it actually causes the battery to lose 40% of its original capacity within that first 20% of the life. Next slide, please, Eva. Mm-hmm. This slide just depicts what happens inside of the battery as acid stratification sets in. Ultimately, you end up with almost all water in the top 1/3 of your battery, and you end up with almost all acid in the bottom 1/3 of your battery. Now, again, this is a 100-plus-year-old problem in the lead-acid battery, and IQ had a simple mixing technology, or has a simple mixing technology that addresses this. Next slide, please, Eva. Mm-hmm. We've won multiple awards, the company has, for this technology, the most recent of which was in 2017, the Gold Medal Green Tech Award in Europe. And back in 2010, the technology won first prize at the Automechanica in Frankfurt. Now, the question always comes up, why, if this technology has won so many awards, why hasn't it been more successful? There's a number of answers to that, but one of the most simple answers is it was early. It was just too early. The industry for decades has had no interest in extending the life of the automotive battery because there was no need to from the consumer side. And on the manufacturer side, it would have meant they would have sold less batteries. Fast forward to today, every single battery manufacturer, every single car manufacturer, every aftermarket parts distributor is now facing warranty issues because batteries for the first time in decades are lasting shorter and shorter periods of time. So innovation has become front and center for every participant in this industry. Next slide, please, Eva. And what you're looking at in this slide is the results of acid stratification. So if you took 2 batteries and you put them side by side, the exact same battery, and then you tore down the battery, you cut it open and looked at the plates after the batteries died, the top plate would be a normal battery without electrolyte mixing. And you'll notice the top 1/3 of that plate is unused active material. So what happens in your automotive battery today, in your lead-acid starter battery, is when it dies, there's still 30 to 50, 60% of the original active material inside of the battery that was unused. and it remains unused, and then it goes through the recycling process. When you can add in mixing, the bottom plate, you'll notice uniform utilization of the surface area of the plate. Ultimately, all we do with this technology, there is no difference in the battery. We simply increase materials utilization, and we roughly double it, which means we get double the cycle life or performance out of the battery from the same battery. Next slide, please, Ava. These are test results. You can slowly flip through the next 2 or 3 slides, Ava. These are test results on multiple batteries in Europe, both with and without mixing. So if you look at the left line on this slide where it says 896, this is a battery from a top European manufacturer called an EFB battery. This is designed for vehicles with start-stop. The alternative to this is an AGM battery, which is largely controlled by Clarios, largely supplied by Clarios. When you add our mixing to an EFB battery, you roughly double the cycle life. And the performance with somewhere around a 30% cost and weight advantage is equivalent to that of AGM. Next slide, please. Next slide, you can go past this one. So mixing was the first technology that IQ had invented, and we've evolved the patents. The most recent patents were issued in 2014 and 2015. But after taking over the company, we have been shifting it to a really clean tech focus, specializing in the battery industry for the time being. And rather than licensing the technology, we've shifted our focus to one that is vertical integration of the technologies into our own battery factories that we will own and operate. As part of that process, we acquired our first factory in Europe in late 2018, and we're in the process of retrofitting that factory with our new manufacturing equipment. We are in the middle or at the end of the process to acquire 2 additional factories. I saw a couple of the questions are, where are those factories, who are those factories? I apologize, I can't disclose who they are because of the confidentiality clauses in the agreements. However, I can say that one is in North America and one is in South America. The reason for that is once you have a Western Hemisphere manufacturing footprint, specifically Europe and the Americas, you cover a great part of the global automotive battery market. And that's important to the major buyers, companies like Bosch or AC Delco, General Motors, Ford. All of the major international brands and auto manufacturers look for a single supply source that can supply them into multiple jurisdictions. And so as we move towards a roll-up of the battery factories, we will accelerate our retrofit of the factories with our new technologies. On the manufacturing side, we're keenly focused on making the lead-acid battery manufacturing process more efficient. Over the years, the industry has not really innovated in terms of making the process itself more efficient. And with our technologies, we're now able to take our manufacturing technologies, we're now able to take a roughly 72 to 90 hour average process down to 12 hours. We can do that while reducing electricity consumption by 25%, water consumption reduction by 90%. We require almost 50% less working capital in the factory, and we ultimately produce a battery that lasts as much as 4 to 6 times longer than the top batteries produced in the same format today. Next slide, please. Mm-hmm. So what are the new manufacturing technologies? Today, there's really 3 primary either bottlenecks or key components to manufacturing a lead-acid battery. Your grid manufacturing, followed by your curing of your plates, followed by your formation of the actual battery. And IQ, along with a number of our partners, have developed technologies that we refer to as concast, concure, and backform. Our new grid manufacturing technology allows us to make what the industry refers to as thin plate pure lead grids. This allows us to remove the calcium and tin from the production process and produce thinner pure lead grids that are corrosion resistant. The curing process generally is a 24 to 48 hour process today. We've moved that down to between 4 and 6 with our curing technology. So we've removed a major bottleneck, and this is a major reducer in terms of goods, working capital requirements for goods and process. But in addition, we're able to produce plates that are totally uniform. Today, the battery, when you produce it, it's only as good as the weakest link, and this removes that issue. So we know that all plates coming out of our curing process are uniform. The formation may be one of the biggest benefits to us. Formation is a 24, again, to 26 or 28 hour process. There is companies in the industry that'll form for more than 5 days. And a lot of times the formation, when it's done, the battery is only 90% formed. And this has been a practice in the industry that has been okay in the past because the vehicle alternator can complete the final formation or full charge of the battery. But with today's increased electronics in the vehicles, it's very difficult for a vehicle today to bring that battery up to full state of charge if it's installed below a full state of charge. Our formation in 4 to 6 hours is able to achieve full formation. And we're able to do formation for both AGM and flooded batteries on the same equipment, which means we don't have to make a bet on which technology for start-stop vehicles, AGM or EFB, is going to win. We can be very versatile and fluid in terms of delivering either product to the market without having to make major capital investments going forward to shift one way or the other. Now, part of our strategy in the industry, there's a lot of inefficiencies. So we add calcium and tin, which adds cost into the grid to strengthen the grid, but it's the calcium and the tin that cause corrosion, so it actually shortens the life of the battery. These are band-aids that the industry has used over the years that we're looking to create systemic solutions. One of our beliefs is the industry operates almost backwards. We ship heavy lead ingots from smelting facilities to battery factories, which create a lot of lead scrap, and we then ship that lead scrap in many cases back to the smelters. When we produce the battery, you add in the very heavy electrolyte, the fluid, and then we ship that fluid all over the continents, and a lot of times even by containers all around the world. One of the benefits of our formation technology is we would be able to produce only dry, unformed batteries at the manufacturing facility, and you'd be able to ship those without fluid to locations globally where you would put our formation technologies, or what we would refer to as a fill and form facility. That provides or allows for significant logistics savings in just doing that, because you're not shipping fluids. So next slide, please, Ava.
Mm-hmm. Growing demand?
Yeah, the market, again, there's been a large misconception for many reasons out there that the lead-acid battery is going to be abolished or it's going to be gone. And I've heard people even say, within 2 to 5 years, the lead-acid battery is going to be gone. Lithium is going to replace it. The lithium battery is not being designed to replace the lead-acid battery in the application. Everybody needs to understand that the batteries are all application-based. Lead-acid will not be used where lithium is used in electric vehicles. Lithium is used for the propulsion of the vehicle. It's replacing the combustion engine, essentially. It is not replacing the lead-acid battery. So lead-acid has been growing at over 10% a year since 2010. There's all sorts of reports, in the market that you can Google, but all of the numbers have been revised upwards, and projections now have the industry somewhere around $52 billion by 2022, and I think they've actually revised that upwards again for a 2025 number. Right now, the industry for starting, lighting, and ignition batteries is around 500 million batteries per year, of which almost 100 million will be for start-stop vehicles this year. By 2025, we're projecting that market will be almost 650 million starting, lighting, and ignition batteries, and between 150 and 180 million just for start-stop vehicles. So although the global battery market, lithium is gaining a larger and larger percentage of the total market, lead acid is still growing at almost 10% a year right now. Next slide, please, Ava.
Mm-hmm. Need for increased cycle life?
Yeah, so just to summarize, within around a 10-year period of time as start-stop vehicles have been introduced into the market, battery manufacturers have been forced to find a way to increase the cycle life of a battery by almost 6 times. So what that means, in Europe, let's say a battery lasts 4 years on average in a non-start-stop combustion engine vehicle, whether it was gas or diesel. That same battery to last the same 4 years in a start-stop vehicle or these more highly electrified vehicles requires almost 6 times the cycle life. And that's what, it's an immediate problem that requires immediate solutions, and the industry is largely overlooked the need to innovate and provide that increase. And I'd say the investment industry has largely overlooked the lead acid sector to provide funding to achieve that. So IQ finds itself in a fairly unique position right now in the industry in that, the last 2 decades of the company's history have been focused on creating solutions in the lead acid space. And those solutions are now coming of age. Next slide, please, Ava.
Mm-hmm. Start-stop segment?
Yeah, and so I referenced this a little bit earlier. This is from Johnson Controls. They did a study, and it showed that in 2017, on almost 450 million batteries, the automotive market required almost 55 million for start-stop. And again, I mentioned that that's almost 100 million this year, and it's growing rapidly to closer to 150 to 180 million in 2025. Next slide, please, Ava.
Mm-hmm. AGM.
Yeah. So the industry has come up with only 2 battery technologies that can supply the 1,500 to 1,800 cycles required by a vehicle with start-stop. If you used a conventional battery in that vehicle, where it used to last 4 years, it would last less than 1 year. And of course, this is an issue with consumers today. So an EFB battery is the same as this conventional flooded battery. It's just enhanced. That's what that stands for, enhanced flooded battery. Versus AGM, the AGM technology that is the dominant technology in the industry today that Johnson Controls, now Clarios, utilizes, was acquired in the early 2000s by Johnson when they bought Varda and Hoppeca automotive divisions from the German battery manufacturers. And in fact, on our team today are a couple of the senior executives from Johnson Controls who've just joined IQ officially September 1st. They led those acquisitions. And today, the technology that Johnson Controls uses is the exact same technology as they acquired almost 20 years ago. Now, they have invested, it depends on which press releases you look at, but somewhere around $1 billion worldwide, preparing their factories to be able to produce AGM batteries for this, call it segment of the market, the start-stop segment of the market. And we will also produce AGM batteries and, of course, have significant knowledge of this technology in-house with the new senior executives coming on board. And of course, our manufacturing equipment will be able to make both AGM and EFB. So we're agnostic to which one the end user would like. However, our EFB utilizing our mixing technology has a roughly 30% cost and weight advantage over AGM batteries, because we're able to achieve the same cycle life as AGM utilizing that technology. So we see this is the higher growth and higher profit margin segment of the industry. And if you are a battery manufacturer that produces anything less than, say, 3 to 6 million batteries a year, you likely cannot afford to invest in changing your factory over to produce AGM. So you're by default moving towards EFB. And there's really no way today to effectively or cost effectively improve the cycle life of an EFB battery without our mixing technology. And the automotive sector is sort of split on the two. Volkswagen largely went with EFB, and that's why if you drive a Volkswagen, you'll see your EFB battery is still in your engine compartment. Mercedes and BMW moved towards AGM, and as of recently, a number have announced moving back towards EFB, partially because AGM is so temperature sensitive. They've had one of the reasons they've had to move that battery out of the engine compartment is because it's temperature sensitive. So now you'll see it, under the seat or in the trunk of the vehicle. Next slide, please, Eva.
Aftermarket.
Yeah, the one point that's I think critical for everybody to understand about our industry, especially in the wake of COVID and an economic downturn, is the aftermarket parts industry, and specifically the lead-acid battery, is countercyclical. We see continued strong demand for batteries in the aftermarket when the economy is weak, which means really people are buying less new vehicles and they're keeping their vehicles longer. And our current business is probably 95%. IQ's current business is probably 95% aftermarket weighted and 5% OE. Over a period of time, we will shift that weighting to a more appropriate mix, diversified mix to 75 to 80% aftermarket, because the global battery market is 75 to 80% aftermarket and roughly 20% OE. But today we've been fortunate. Really, it's just been lucky timing that our current factory and the two acquisitions that we're making right now are largely aftermarket weighted, and the aftermarket is countercyclical. So it's been historically an investment of safety in down economies, as are other aftermarket parts. It's people. One of your parts on your vehicle that you cannot delay replacing if you want to continue driving is your battery. When the battery dies, you have to get it replaced. And that leads me to a point regarding COVID. What we're seeing right now in the market, and we put out a report on this in March, I believe. I'm not sure if any of the shareholders on the call saw the report, but it certainly went out to a number of people, predicting that there may be a COVID-related spike in batteries. So while the industry was actually reducing inventory at the manufacturing level and in the distribution level, when vehicles sit, batteries self-discharge, and they ultimately discharge to a deep state and batteries die. And you see that a lot when vehicles sit. And because of COVID, more vehicles than usual were sitting. And, and I'm sure people have experienced this or know somebody who has already. Batteries, when they went to start their vehicles again, batteries died. And in Europe, this was an exacerbated issue because Europe is sitting on 3 unusually warm winters, where if you have a cold snap of at least 2 weeks, that's generally when you see batteries die. But Europe's batteries didn't get exposed to those cold snaps over the last 3 years, and so they're on what we refer to as borrowed time. Next slide, please, Eva.
Environmental impact.
So as a company, we're shifting the company towards a technology company, and again, vertical integration. Everything that we do is focused on the environmental impact. And again, I think lead-acid batteries, because they have the word lead in them, have a negative stereotype. But lead-acid batteries are the most recycled consumer item in the world. It's the most successful recycling or circular economy example that there is. 97 and 99% of batteries are recyclable, and almost 99% are recycled. We want to continue to make this better. We've recently signed a license to a new battery recycling technology that will now make the recycling side of the industry more efficient, roughly allowing them to reduce emissions by up to 85%. Of course, if all the industry used, the slide that you're looking at right now was a study that was done, I think, back in 2010 or 2011. But if our mixing technology was the universal standard in every single battery worldwide, you would significantly reduce materials, or put a different way, materials utilized, put a different way, you would significantly reduce the weight of the battery and have the performance the same. So, of course, every gram of weight you can remove from a vehicle today translates into fuel savings, which translates into emissions reduction. In addition to this, we're looking at ways to take our battery manufacturing facilities off-grid. I already mentioned earlier that we've already been able to reduce over best-in-class processes today, electricity by 25% and water by 90%. With some of the new technologies on the recycling side, we're going to be able to give recyclers the ability to reduce their emissions by up to 85%. And so this is a keen focus of the company going forward. I mentioned earlier that we're looking at utilizing the lead-acid battery infrastructure that we're creating right now as the future catalyst to move into other areas. And, of course, one of those areas is going to be advanced battery manufacturing as well. So the presentation that Vincent made on Vulcan was interesting to me. I think it's great that the European Union is moving towards generating raw materials. We believe the current lithium-ion battery is already displaced. It's going to be leapfrogged towards a lithium-ion or other chemistry-based solid-state battery, and that's one area that we're going to be focusing on as well. Next slide, please, Eva.
So that would be already the questions. Next slide, or do you want to see this one, the battery?
No, that's good. Okay. The next slide will be questions.
Yeah.
So I think just to summarize, we've spent the last 2 years transitioning the company. We're very close to having turned the corner on that first transition to where we will have our owned and operated manufacturing facilities, deploying all of our technologies. We will continue to look to expand our geographic footprint for manufacturing. Right now, we will have a very strong Western Hemisphere manufacturing footprint. Part of my focus going forward in 2021 will be to try and find another opportunity that will be synergistic with that existing footprint. And then the next step after that will be to overlay additional manufacturing opportunities of more advanced battery chemistries that will ultimately end up with our exact same customer base. And with that, I'll turn it back over to you, Eva.
So thanks a lot. Vielen Dank. By now, if I see it correctly, nobody has dialed out. Bisher hat sich wohl offensichtlich noch niemand ausgewählt. I think this shows how fascinating and interesting is this whole theme for everybody. Ich glaube, es zeigt auch, wie spannend das ganze Thema für jeden ist. We will now start with the also 8 or 9 questions for IQ International. I start with the first one. Inwieweit sind die Batterien von IQ International AG bereits im Ersatzteilemarkt vertreten mit der Marke Mixtec und welche weiteren Vertriebssegmente sind geplant? So, to what extent are IQ International batteries already represented in this spare parts market with the Mixtec brand, and what are other sales segments are planned? Which other sales segments are planned? Kevin?
Sorry, Eva, can you hear me?
Yes, I can hear you. Yes.
Okay, good. Just so you know, I did forward you responses, so if it'll help you to pull up that email as you're translating this, they are in your inbox, but I'll try and go through it slowly.
Wonderful.
The Mixtec, well, I won't talk about the Mixtec brand because that's just one of our licensees' brands, but the mixing technology to date has been installed in roughly 4 million batteries worldwide. And to put that into perspective, the battery industry is almost 500 million per year. So it's had a very small, it's made very small inroads into the market, but the timing is such that the technology is relevant today, whereas historically it hasn't really been relevant. It's been an amazing technology, but it just wasn't needed. And today it's absolutely needed. So we anticipate, a great deal of different opportunities and sales segments. Either one, to produce a battery at a lower cost that lasts as long as the incumbent batteries. That's one segment that we'll be going after, or call it product positioning. And number two, and specifically in the EFB battery, it gives us the ability to take an EFB battery to AGM performance again, but at a lower cost. So currently very small market penetration, but the timing is important, and it's the timing is very good now.
So thanks so much. Momentan ist es so, dass etwa bisher in 4 Millionen Batterien diese Technologie verbaut worden ist. Es gibt aber derzeit etwa 500 Millionen Batterien. Das heißt also, es sind bisher eben nur ein kleiner Bereich verbaut worden, aber eben anders als in der Vergangenheit ist das Timing sehr viel besser heute, weil einfach diese Technologie relevant ist für den Markt. So, die nächste Frage wäre, wie ist der Status der Zusammenarbeit mit Mura? What is the status quo of the collaboration with Mura? Kevin?
Sorry, I muted again while you were talking, so you couldn't hear my background noise. The collaboration with Mura has been stagnant for a number of years. I think they put the technology in roughly 180,000 batteries last year. And, you know, based on the agreements that were in place, we utilized that, you know, call it minimal performance as a way to free up our ability to produce our own batteries in South America, which was very important in advance of acquiring our own factory in South America. So we'll continue to collaborate with Mura and are continuing to speak with at least a half a dozen other top manufacturers worldwide about collaboration on both our mixing technology and some of our other technologies. But as of right now, the Mura collaboration is really just status quo. There's been no real advancement in it.
Mhm. Also momentan stagniert diese Kollaboration, aber man spricht eben weiterhin auch mit Mura und aber auch mit einer ganzen Reihe weiteren möglichen Partner, mit denen man zusammenarbeiten möchte. Die nächste wäre, wie ist der Stand der Verhandlungen mit der Firma Bosch? What is the status of negotiation with the Bosch company?
I can't comment on it. I can't comment on Bosch until we are either legally able or required to make that information public.
Also da darf er momentan nichts drüber sagen, keinen Kommentar zu abgeben, bis er eben dazu berechtigt ist. Dann geht es um die Umsetzung von Vorhaben und Produkte, Implementation of Products Production. Welche Vorhaben kann IQ International derzeit schnell umsetzen? What projects can IQ International currently implement quickly? Batterien mit längerer Lebensdauer, Batteries with longer lifetimes, effizienteren Produktionsprozess, efficient production process, Einsparung von Rohmaterialien, Saving of Raw Materials, Recycling-Möglichkeiten, Recycling Possibilities.
Well, it depends on what everybody thinks is quickly. So, you know, if quickly is in a 30 to 60 day period, to answer the first question, batteries with a longer life cycle, the general process to include our 360 mixing technology in a battery is about a 60-day process. So that doesn't take too long. Sometimes we have to make a new mold to make the parts, but generally speaking, we have the molds that fit most batteries worldwide now. So that's a fairly quick process. So maybe I'll let you answer that one first.
Also es hängt so ein bisschen davon ab, inwieweit oder was man als schnell letztendlich versteht. Und der Prozess selber der 360 Mixing-Technologie ist üblicherweise in etwa 60 Tagen gemacht oder durchgeführt.
So, you know, if you look at, I still think quickly is less than 12 months. In our planning and in my planning for the company, you know, I'm looking out 5 and 10 years now. So efficient production process, you know, including our manufacturing technology, that takes longer, but most of that is dependent on, you know, our manufacturers of the equipment itself. And generally speaking, our lead time is around 9 months now. So I would say that we are able to install equipment and test the equipment in a new battery factory, you know, within around 9 months.
Also zur Frage nach dem effizienten Produktionsprozess, da reden wir von ungefähr 9 Monaten. Yes?
So savings of raw materials. Well, there's two different answers to this. One is we can immediately save raw materials by using the 360 mixing technology. Remember, that technology does one of two things. It either doubles the life of any battery it goes into on average, or alternatively, you can reduce the materials in the battery and have the battery perform the same.
Okay, zur Frage nach der Einsparung von Rohmaterialien. Das ist eben das Resultat vom Herstellungsprozess und nichtsdestotrotz kann man eben auch die 360 Mixing benutzen, um eben solche, die Materialien und damit auch die Materialienkosten einzusparen. Mhm.
On the manufacturing side, you're talking about 9 months again, and we use less raw materials in the manufacturing process. If you look at just the concast machine as an example, when we produce a grid, a thin plate pure lead grid, the average thickness of that grid is maybe 0.7 millimeters thick. And when you produce a grid, you generally want thickness at the lug, not in the wire themselves. So our lug is closer to 1, but the average is about 0.7. In the industry, the average is somewhere around 1.2 to 1.3 millimeters thick. And so we will have material savings the moment we install the concast machine. We also have material savings potential in the curing because we get higher amp hours per plate on average than the standard curing processes. So there is raw material savings tied to the manufacturing technologies, but this is going to be realized over the course of the 9 months as we retrofit factories.
Mhm. Ich muss auch hier so ein bisschen auf die Tube drücken. Wir sind inzwischen eine Viertelstunde drüber, so we are already 15 minutes over time.
Yeah.
Just in a nutshell, es gibt also an ganz zahlreiche Stelle verschiedene Möglichkeiten, Rohmaterial einzusparen. Should we go to the next one?
Yeah, and you know what, Eva, I can make it a little quicker because I think I answered a number of these questions throughout my presentation.
Yeah.
So why don't we skip, is 360-degree electrolyte mixing already integrated? And SIA, yes, it is. It's ready to be integrated, and we're planning on shipping the commercial orders starting in Q4, but it's already been integrated.
Mhm. Also die 360 Grad, das ist die Frage der SIA 360 Grad Elektromischung, ob diese bereits integriert ist. Ja, sie sei bereits integriert.
So the battery factory in Germany, I don't have a final answer on this yet, but I can say that we are working on the project.
Also zur Frage, inwieweit die Batteriefabrik in Deutschland bereits gebaut wird, wie der Stand ist, da gibt es noch keine finale Antwort, aber man ist eben dabei, ja.
Germany is a core focus for us going forward. We want to have a manufacturing presence in Germany, not only for lead acid batteries, but for advanced batteries as well.
Also Deutschland stellt, ähnlich wie wir es vorhin schon gesehen hatten, ein zentraler Fokus dar für die verschiedenen Batterietypen von IQ. Mhm.
So for SIA, the current planning is we'll have it fully retrofitted within 10 months from closing the commercial funding we're working on right now.
Also da war die Frage eben, wann dieses Vorzeigewerk eröffnet wird, da reden wir von etwas so in 10 months. Is that correct? In 10 Monaten.
Pardon me?
In 10 months. In 10 Monaten.
Yeah, in 10 months from the time we close the financing. Yeah.
Also in 10 Monaten, nachdem die derzeitige Finanzierung abgeschlossen werden konnte. Mhm.
Yeah. Again, to two battery factories, I mentioned this earlier, I'm prohibited from disclosing which factories those are because of the confidentiality clauses, but I can say that one is in the United States and one is in South America.
Mhm. Also zur Frage, welche beiden Batteriewerke IQ plant zu kaufen, da kann Kevin das nicht oder darf er es nicht beantworten, aber eines ist in Lateinamerika und eines ist in den USA. Mhm.
And so for the last question, I think, IQ is a clean technology company now. That's what we are. We're also a manufacturing company, but utilizing clean technologies. So we intend on focusing to continue to make the lead acid battery infrastructure cleaner. And we have our engineers in-house. One of the projects they're working on is how to take our factories totally off-grid. And although I can't comment on the hydro technology to a great extent yet because it's still in analysis and in assessment, it's one of the ways that we are looking at whether or not we can take the factories off-grid. Again, reducing the carbon footprint of the industry.
Also bei der Hydrotechnologie geht es vor allem darum, die derzeitigen oder den CO2-Abdruck der jeweiligen nicht der Batteriewerke, also der Fabriken letztendlich deutlich senken zu können. So last question, für wann ist das Listing an der Nasdaq geplant? When is the listing on the Nasdaq planned?
We don't know. We don't have a time date for this yet. This is going to depend on, there's a lot of factors that are going to influence this over the next 3 months. We probably won't have a timeline until early next year.
Also da gibt es noch keinen Zeitplan, den wird es vermutlich Anfang kommendes Jahres geben. And maybe really the last question, which advantages do you see if you compare the lead acid batteries to lithium-ion batteries?
Yeah, you bet. Again, batteries are application-based, and there's certain benefits that lithium has that lead acid will never have. An example would be energy density. Lead acid will not be used in electric vehicles for propulsion. But where lead acid is clearly a leader, or clearly the right application or option, is in the starting, lighting, and ignition side of the industry. Also, we are working on a project, and we think within 6 months of having some equipment installed in Italy, we will have completed the 48-volt lead acid battery project. This is a battery that the mild hybrids currently use lithium for, because there is not a lead acid option, but where lead acid would have great benefits in terms of cost and performance. And also lead acid is still critical for the grid infrastructure or major energy storage systems. I think what you'll start to hear more of finally is people talking about co-chemistry storage installations or battery banks. And for one example, you could put lithium with lead acid as a storage application on the grid, and it would be a lower cost storage installation. And if you need very rapid power, so you needed, a megawatt in 1 minute, it would be the lithium battery bank that provided that. But if you needed 1 megawatt over 10 hours, it would be your lead acid battery bank that provided that. So they're very application based, but those are a couple of applications that will continue to make great sense for lead acid.
So thanks so much. Vielen Dank. Das war die letzte Frage. So just in a nutshell, ganz kurz zusammengefasst. Also Kevin sieht im Vergleich zur Lithium-Ionen-Batterie eine ganze Reihe von Vorteilen, die aber letztendlich von der tatsächlichen Nutzung der Batterie abhängig sind, beispielsweise als Starting Machine oder bei den Kosten, bei der Performance oder aber auch wenn es darum geht, Strom in Batterien überhaupt zu Storage letztendlich. Gut, das war's für heute. Die allermeisten sind nach wie vor da. So the most participants are still dialed in. Entschuldigen Sie bitte, dass es etwas länger gedauert hat, aber ich glaube, es war super spannend. I think it was extremely interesting. Thanks a lot, Kevin. Do you want to have one further sentence and then we would stop the conference for today? Hat sich wieder muted. Kevin? Offensichtlich ist er muted. Ich schaue noch mal kurz, ob er sich noch mal... Kevin, do you want to say one last sentence? No. Scheint mich nicht mehr zu hören. Dann darf ich mich ganz, ganz herzlich bedanken bei allen Teilnehmern.
Hey.
Ja.
Hey, sorry, I got kicked off for a minute, but I'm back in.
Just one last sentence before I close the conference.
Yes, please. No, I'm good. Thank you, everybody, for their time, and thanks for staying overtime. I appreciate it.
So, thanks a lot. Vielen Dank. Und ich darf mich ganz herzlich für Ihre Teilnahme bedanken. Und dann würde ich mich freuen, wenn Sie bei einer der weiteren Konferenzen wieder dabei sind. Thanks a lot, everybody. And I would love to welcome everybody again for one of our next virtual conferences. Thanks a lot.
Thank you, Eva. Bye-bye.
Bye.